This video is over lessons 44 through 46. Lesson 44, simplify decimal numbers, comparing decimal numbers. Lesson 45, dividing a decimal number by a whole number. And lesson 46, writing decimal numbers in expanded notation and mentally multiplying decimal numbers by 10 and by 100. Take a moment to copy the title into your notes. This video will continue in 3, 2, 1. Simplifying decimals means getting rid of zeros that we don't need. So for example, let's take a look at 0.005200. Now, obviously I'm going to leave the 0 that's a placeholder for the whole numbers. But the question is, can I get rid of these zeros, or all 4 of them? So let's take a look at it one group at a time. We'll look at these and these. So, first of all, let's get rid of these. So if I get rid of those, I have 0.5200. Skip a couple spaces, and let's do it again. But this time, let's get rid of these last 2 zeros. So 0.0052. Well, if we take a look at place values, over here in the 10th place, I have a 0. But over here, I have a 5. Well, if I've got different things in the same place value, this obviously cannot be equal. And so what we see here is when there are zeros that are pushing other digits away from the boundary, away from the decimal place, we have to keep them. But what about these? Can I drop these? Well, again, let's look at the place values. So we have the tenths here and the tenths here, both zeros. Then we have the hundredths here and the hundredths there, both zeros. And we've got the thousands here and thousands there, both 5s. And the 10,000ths here and the 10,000ths there, both 2s. But if we keep going, in the 100,000ths I have a 0. Over here in the 100,000ths I have nothing. Well, nothing in a way is the same as 0. So those are still the same. And then finally, in the millionths and the millionths, again, 0 and nothing. So these two actually do match up. So if zeros are not holding anything away from the decimal, we can drop them. In other words, if they're hanging off the end of the decimal. As an application of this concept, let's consider the problem 0.8 times 0.5. Well, to multiply decimals, we multiply as if they were whole numbers. So 8 times 5 would be 40. But then we have to count up how many decimal places they have. So this is 1. This is another 1 for a grand total of 2. So if I put the decimal right here, I have 2 decimal places in my answer. 0 out front as a placeholder. And I can see that I have this 0 hanging off the end. He is not keeping anything away from the decimal, and so I can reduce this. So this would be equal to just 0.5 4. This video will continue in 3, 2, 1. In order to compare decimals, we need to take a look at their place values and see which one has a larger digit in the highest place value. So for example, if I want to compare 0.042 with 0.21, I'm going to take a look at their place values. So, in the ones place, which is the highest place value, they both have zeros, so we got to move on to the next. In the tenths, this has a 0, and this has a 2. Well, 2 is bigger than 0, so I can stop right there, and I know that this number is going to be larger. And so, the alligator or the Pac-Man or whatever you want to call it or think about it as is going to eat this larger number. So 0.042 is less than 0.21. Let's take a look at another example. 0.01, and we're going to compare that with 0.000998. At first glance, when we see just a 1 there, and then what looks like 998, we're tempted to assume that this number is bigger. But we can use a little trick to help us see that it's really not. One thing you can do is actually line up your place values. So underneath here, I'm going to actually line these place values up. So 0.01, and then below that, 0.000998. Now obviously we can see that we've got a lot of empty places here. So what I'm going to do is I'm going to unreduce that decimal. In other words, I'm going to take some of those invisible zeros and write them in. So if I write those in, and now we take a look at what these numbers look like. Well, this now no longer looks like 1, it looks like 1,000. And this still looks like 998. Well, obviously, if you compare 1,000 and 998, we know that 1,000 is greater. So 0.01 is greater than 0.00998. Moving on in 3, 2, 1. Dividing decimals by whole numbers. Let's go ahead and work through 2.5 divided by 8 as an example. So first of all, if I'm doing this division problem, I'm probably going to put it in a division box. The first number always goes inside. So that means I'm going to have 2.5 on the inside there and 8 on the outside. The very first step is going to bring up my decimal. So I bring up that decimal, and from here on out, it's just normal division. So 8 goes into 2 0 times. And now 8 goes into 25 3 times. 3 times 8 is 24. 25 minus 24 is 1. Now, I can't mix fractions and decimals. You cannot take this 1 and turn it into 1/8. That is a huge mistake. You cannot mix those. Once you've decided to go decimals, you have to commit to it and keep going. So, I need something more to bring down. Well, this is where we need to remember that we have as many invisible zeros at the end of my decimal as I need. We usually reduce them and drop them, but they're still there, they're just invisible. So if you need them, put them in. So now I've got that 0, and I'm going to bring it down. Now, 8 goes into 10 once. 1 times 8 is 8. Subtract, and we get 2. Always remember that before you put something up here, something has to come down first. So you got to come down before you can put something up. So I've got to bring down another 0 before I can put something up. So now 8 goes into 20 twice. 2 times 8 is 16. 20 minus 16 is 4. Gotta always bring something down before I put something up. So bring down another 0. And 8 goes into 40 5 times evenly. And so my answer is 0.3125. Moving on in 3, 2, 1. Expanded notation means writing a number as the sum of each non-zero digit times its place value. So, just because we're using decimals now, that's not going to change. So let's go ahead and take a look at 24.053. So we start with the largest digit, which is 2. So 2 times its place value, well, there's the ones place, so that's the tens place. So 2 times 10. It's a sum, so I've got to add on the next digit. And the next digit's 4, which is in the ones place. So 4 times its place value, which is the ones place. Now we're crossing over the decimal. So these are now decimal places. I'm going to skip the 0 because I'm only looking for the non-zero digits. In other words, I'm looking for what we actually have, not what we don't have. So I'm going to move on to this 5. Well, the 0 was in the tenths place, so the 5 is in the hundredths place. So I'm going to add on 5 times, this is where we need to remember that decimals are really just special fractions. So it's in the hundredths place. So 1/100th. And then finally, if the 5 is in the hundredths place, that means that this 3 then is in the thousandths place. So this is 3 times 1,000th. And there's 24.053 written in expanded notation. And let's do one more example. Let's take a look at 80.7. So my largest digit there is the 8 times its place value. So that's the ones, so therefore this is the tens. So 8 times 10 plus nothing in the ones, so I move on to the tenths. So 7 is in the tenths place. So 7 times 1/10. So 80.7 is this in expanded notation. Moving on in 3, 2, 1. Our number system is based on 10, which means that each of our place values is a power of 10. So 1's a power of 10, 10 is obviously a power of 10, 100, 1,000, 10,000, 100,000, million, and on and on and on. Each of them is a power of 10. So when multiplying by a power of 10, since these are based on our place values, simply move the decimal. Moving the decimal moves the boundary between the whole numbers and the decimal places, which therefore also moves each of the place values. So let's take a look at some examples. Let's say I have 0.42 and I multiply that by 10. Well, 0.42 times 10, little shortcut here is since there's only one 0 there, the place values are going to shift once. So 0.42 is going to have its decimal move once. Multiplication makes the number bigger, so I got to think about it. Which way am I going to go to make this bigger? If I move the decimal this way, well, does that make it bigger? No, it actually makes it further away from having a whole number. But if I move it this way, suddenly I go from having no whole numbers to having 4 whole numbers. So that's the way to go to make it bigger. So moving it once makes it 4.2. So my answer is 4.2. How about if we had 5.7 times 100? Well, 5.7, and then because there are 2 zeros here, we're going to move the decimal twice to make it bigger. Well, moving it this way will make it bigger because it goes from a 5.7 to a 57, but that's just moving it once. I need to move it a second time. So there's my new decimal. This empty space then gets filled with a 0. So my answer to 5.7 times 100 is 570. As you become more comfortable with this, you should come to the place where this and this can be done in your head. And so these problems become mental math. Remember, for mental math problems, showing your work means copying the problem down. This video ends in 3, 2, 1.